Well, hello geometers and seekers of general truths. In this video, we continue our study of inscribed angles by looking at something a little bit different. So we have a measure of an arc here that is 139 degrees, and we're asked to find the measure of the inscribed angle. And again, it's very tempting to say that this angle is 139, but it's not, right? It's the central angle here that is 139. So angle CAB, that's the one that is 139. So I'm gonna just highlight this whole section here. The arc being 139 is exactly the same thing as the central angle being 139. So I'll write a note on the side here. Angle CAB is equal to 139 degrees. And our goal here is to figure out the measure of angle CDB, so this one right here. Okay. And we're going to employ a very similar trick to what we had before by using some triangles and some isosceles triangles for that matter. Okay, so what I'm going to do here is construct a diameter that goes from D through A. All right, so from this picture, we can point out a few things that DA, CA, and BA are all congruent to each other because they are all radii of the circle. So remember, this is one of the strategies that we want to employ, is using radii of the circle. And notice here what we have is a couple of different isosceles triangles. So the first isosceles triangle that we have is CDA. So this one right here, CDA, that's an isosceles triangle. And because of that, this angle right here, ADC, and this angle here, ACD, have to be equal to each other. They're both x degrees, whatever x may be. Okay. And not only that, we can take it a step further and we can say that this angle here, ADB, right, we can label that y, and that's congruent to this angle down here too, ABD. That's also equal to y. So from here, I'm going to refer you back to the external angle or the exterior angle theorem, just because that speeds things up just a little bit for us. All right. But if you notice here that using this exterior angle idea, that let me just name this point here E. Okay. That angle CAE is equal to x plus x, or 2x. Okay. So angle CAE is equal to 2x. And I'm going to draw that picture on the side here so you can see. So let me see if I can replicate this picture here. So CDAE. So from C, right, to D, here's A, and here's E. Okay. And here's this line here, right? And this is x, and this is x, right? So notice angle CAE is the exterior angle, so it must be equal to these two interior angles added up together. So that's equal to 2x. So that's this angle here, CAE. Okay. Now, if we look at the other picture down here, this triangle BDA, this triangle, that tells us that angle BAE has to be equal to 2y. Right, and I'm going to explain that as follows. Okay, and the reason that we can say that angle BAE is equal to 2y is as follows. So I'm going to sketch out this triangle for you from B to D to A and to E. So here is B to D, A, and then E out here. Right, so remember that this is y, this is y, right? This is an isosceles triangle. So using the exterior angle theorem again, y plus y is equal to this angle out here, which must be equal to 2y, right? So y plus y is 2y, and that's this angle out here, right? So again, the exterior angle theorem gives us a really nice piece of information that we can now use, okay? Okay, so where are we going with this, right? So it seems like all I've done so far is introduce a bunch of letters and variables that kind of make the problem more complicated. But often in mathematics, when things seem to be so complicated, it means we're just about to get to the right answer. So let's look at this picture again, and let's look at this red angle right here, CAB. You see that? CAB is really a combination of CAE, right? That's this one that says 2x, and BAE, that's this one that says 2y. So we can say that 2x plus 2y is equal to 139 degrees. Okay? And we're not going to solve for x and y. We're just going to try to simplify this a little bit further, factor out the 2. So x plus y is equal to 139. Then divide both sides by 2, and that gives us 69.5, okay, is equal to x plus y. Now this seems weird that we have two variables, we don't know either of them, and we happen to just have an answer for the combination of them. But that's okay, right? Because if you look at x plus y is the measure of angle D, right? So if you look at, if I'm gonna temporarily erase this for a moment, right? X and y, right, together they form angle CDA or CDB, right, which is the thing that we're trying to find in the first place. All right, and there you have it. We've actually arrived at our final answer, that the measure of angle D, or more specifically, the measure of angle CDB, is equal to x plus y, which equals 69.5 degrees. Okay, so a slightly more complicated example, but we still get to the final solution, the final answer here. And again, our approach is the same as it was before, using isosceles triangles, using the radius of the circle, right? So when we have a circle, we know that its radii are always equal to each other, and using that fact with an old theorem here helps us get to where we are. As always, keep working hard, ask for questions when you need it. Thank you for watching, and have a wonderful day.